Hello students, welcome to this introductory session of data link layer. The data link layer is the second layer of the OSI layer stack. It comes after the physical layer. Till now, we have discussed the physical layer in detail, and from now on, we will try to understand the data link layer in detail. This session includes the responsibility of data link layer in brief, and if possible, we will also try to see what is the physical address and the frame structure of data link layer. So let's start. Here you can see that different devices are connected to each other via link. Here all the devices are connected via router and it creates a local area network. Here, different devices are also connected to each other via router or switch, and that also creates a local area network. And these local area network are connected to each other via routers. Now, this is the network of networks, and which is also known as Internet. And in the Internet, individual device is known as node. So the first and the most important responsibility of data link layer is to deliver frame from one node to its adjacent node only. So this router can deliver frame from here to here or from here to here. And it is the responsibility of data link layer. So this point is very important, that the link layer has the responsibility of transferring the datagram from one node to physical adjacent node over a link. Now let's discuss different responsibilities of data link layer. And the first responsibility is framing. In the figure, there is a device A that wants to send data to device B. Now we are discussing the responsibility of data link layer, so we will consider the layers up to the data link layer. So now you can see there are only two layers. Now suppose device A wants to send data to device B. So the frame will be generated in the device A, and when that frame is transferred to physical layer, it will be converted into bits. Suppose that device A's frame, when the device A's frame is converted into bits, there are 4 bits, and those 4 bits will be transferred via this link. And device B will receive these bits and it will be delivered to device B data link layer. Seems very easy and straightforward, right? But this is not the case always. Suppose there are two devices that are transferring the data at the same time. So device A is also transferring the data and device C is also transferring the data. So when device A wants to transfer data, the frame will be generated, and when that frame is transferred to physical layer, it will be converted into bits. Notice that there are 4 bits in device A's frame. And when device C wants to send any data, the frame will be generated in the data link layer, and when it is passed to the physical layer, it will be converted into bits. Now suppose when the device C's frame is converted into bits, there are 6 bits, and those bits will be transmitted over link. So on the link there are stream of bits. So all the device B is receiving a stream of bits. Now device B will get confused because device B doesn't know the size of the device A's frame and device C's frame. So device B will be confused that from where it has to start receive the data until where it has to stop receive the data. So this is known as framing. So it is a responsibility of the data link layer to provide something so that the receiver will know that this is the start of the frame and this is the end of the frame. Because in the physical layer, it is a stream of bits which is transmitting from the sender to receiver. So the sender must provide something so that the receiver can identify the start of the data and end of the data. And that thing is called framing. The next responsibility is the flow control. Suppose device A wants to send data to device B, and A and B are connected to each other via link of having R bits per second. And suppose value of R is 2 Mbps. It means that this link can carry data at 2 Mbps. So suppose if device A wants to send data at 1 Mbps, there will be no problem because link can carry data at up to 2 Mbps. So device A can send data at 1 Mbps very easily. But suppose device A wants to send data at 4 Mbps. Now there is a problem, right? Because the link can carry the rate at up to 2 Mbps, but device wants to send 4 Mbps and there will be loss of data. Now in this case, even if device B is able to receive data at 4 Mbps, link is not able to transmit data at that rate and there will be loss of data. So the device A should send data at particular rate so that there will be no loss of data, and which is called flow control. The next is error control. Error control means that when the data is sent to link, there is a possibility that noise can be added. So suppose there is a data which is transferring from A to B, and if noise is added, there is a possibility that the value of particular bit can be changed. So it is the responsibility of data link layer to provide such mechanism so that if there is a error in data, receiver can detect it. And if receiver knows that there is error in data, it is a responsibility of data link layer to correct the error. The last responsibility is the multiple access control. Now what is the multiple access control? Here you can see that devices such as A, B, C, D and E, all the devices are connected via a single link. Now suppose all these 5 devices start sending data at the same time, there will be collision in the network. Collision means that all the data which is sent by all devices will be mixed up and it will be corrupted. And when the data is corrupted, receiver will not able to understand what is the data and what is the meaning of that data. So it is also responsibility of the data link layer when the channel is shared. So it is a responsibility of data link layer to provide the efficient utilization of the shared medium. Now the question is, where is the link layer implemented? The link layer is implemented in each and every host. It can be found in network interface card or on a chip. So devices such as laptop or desktop or in routers, the link layer can be found on network interface card, or in devices such as mobiles or tablets, it can be found on a chip. And the link layer is the combination of hardware and software. But what is the meaning of the combination of hardware and software? So let's see more about it. This is the figure or photograph of the network interface card, which can be found in laptop or in old PCs. Here you can see the computer has many components, such as there is a network interface card and there is a memory, the central processing unit, and all these blocks are connected via a high-speed bus. So the data link layer is implemented on the hardware part and software part. So it is implemented in the network interface card and to the CPU as well. Suppose that device A wants to send any data to device B. Now we are assuming that in the application layer some data is generated and that data is passed to the application layer, from the application layer to transport layer, and the data is now reached to the network layer. And in the network layer it is called datagram, right? And when that datagram is passed to the data link layer, it will be encapsulated and it will be called frame. And when the datagram is encapsulated in the frame, some header will be added at the data link layer. So the datagram is passed to the data link layer and it is encapsulated and some header is added. At the data link layer, we are also adding extra information so that the receiver can know whether the received frame has any error or not. So the frame is transmitted to the receiver and it is reached at the receiver's data link layer. And when it is reached to the receiver's data link layer, it will be passed to the network layer, and there it is called datagram. And after that, it will be sent to the application layer. Now, this is the frame format of the data link layer. As you know, the packets or datagram is generated in the network layer. And when it is passed to the data link layer, some trailer and header will be added and together it will be called a frame. So this is the frame structure of the data link layer. It has many fields such as preamble, then SFD, destination address, source address, length or type, data padding, and the CRC. Let's see one by one. The first field is preamble. The size of this field is 7 bytes. Preamble used to synchronize the receiver, and its value is 1 and 0 for 7 bytes. So how it is used to synchronize a receiver? Let's see. The value of the preamble is 1 and 0 for 7 bytes. Let's write it down. So it will be something like this for 7 bytes, right? If you convert these bits into signals, you can see something like this. And this signal is nothing but a periodic signal. And a periodic signal has a characteristic like frequency, right? So when the receiver receives this type of signal, from this signal, receiver will interpret the frequency of the incoming signal and it will synchronize itself with the frequency of receiving signal. So the preamble is used to synchronize the receiver, right? The next field is the SFT, which is called Start Frame Delimiter. The value of the SFT is same as preamble, but only difference is that last two bits are 1-1. Okay, so when the receiver detects last two bits 1-1 after continuous 0 and 1, it will know that this is the start of the frame. And the next field is destination address. The size of the destination address is 6 byte and it is same as the source address, which is also 6 bytes. And in the destination address field, there will be MAC address of the destination device, and in the source address field, there will be MAC address of the device that is sending the data. The next field is length or type, which is of 2 byte, and and from this field you can know the length of a frame. The size of the data and padding is 46 bytes to 1500 bytes. And the last is CRC, which is called cyclic redundancy check, and this field is used to detect error. We will see in detail how the error detection is done using the CRC method, but now we will just see the meaning of this field, but later we will see the CRC method in detail, and the size of this field is 4 bytes. Now let's see the MAC address in detail. The MAC address is also called physical address, and the size of this address is 6 byte. And there are total 12 hex digit, which means the size of one MAC address is 48 bits. So in MAC address, each digit is represented in the hexadecimal, right? And when it is converted into binary, each number represent 4-bit value. This thing is known by you, right? The MAC addresses allocation is administered by IEEE, and there are total 2 raised to 48 addresses are available worldwide. So if any manufacturer wants to use MAC address, they have to purchase a slot of MAC addresses from the IEEE, and without it they can't use Without the permission of IEEE, no company can use MAC address for their devices. And the MAC address is unique number and it cannot be same for any two devices. So no laptop or mobile or two laptop or two phones or two any devices can have same MAC addresses. There are three type of MAC address: unicast, multicast and broadcast. Unicast means that this address is one to one. Multicast means that this address is for one to many. And the broadcast means that that address is one to all the devices. So how do you know that particular MAC address is unicast, multicast or broadcast? So this is the example, this is the MAC address and I want to see that whether this MAC address is unicast, multicast or broadcast. So to check, we have to see the first byte of the MAC address. In the first byte, the LSB, if the LSB is 0, it means that that MAC address is unicast MAC address. If the LSB is 1, it means that that MAC address is multicast MAC address. And if all the bits, all the 48 bits of the MAC address is 1, it means that it is broadcast MAC address, right? So let's see the first byte, LSB of the first byte in this example. So when you convert the first byte, you will get number like this: 0100 for the digit 4, and for A it will be 1010. So we have converted the first byte into binary. After converting, we will check the LSB. If the LSB is 0, it means that this MAC address is unicast, means 1 to 1. If it is 1, then it is multicast, which is 1 to many. And if all the bits are 1, all the 48 bits are 1, it means that it is broadcast, which means 1 to all. So you have to find yourself these two MAC addresses, type of these two MAC addresses, whether they are multicast, unicast or broadcast. So this is the end of the session. If you have any doubt, you can ask me in the comment section. Thank you everyone.